Okay, so here is my dynamic model on the parabola for the week 11 task 2. So I'll just share my screen now to show the Solidworks model. So here we have the dynamic model of the parabola. So what we have is a right cone, we have a cutting plane, and we also have a focal sphere. So if I zoom in on the focal sphere, we can see that the focal sphere is tangential to both extreme generators of the right cone. The focal sphere is also tangential to the cutting plane, which is the cutting plane through the right cone. So we then have a parabola projected to one side. So we know it is a parabola because the cutting plane is parallel to one of the extreme generators of the right cone. So the focal point, or the focus of the parabola, is obtained where the focal sphere touches the cutting plane at a tangent. So the directrix DD is also obtained where the focal sphere meets the extreme generators at a tangent. At these 2 points, a cutting plane or another plane is introduced to the right cone, where this new plane intersects our cutting plane to produce the parabola, results in the directrix. So the axes then can also be seen, and the axes meets the directrix at 90 degrees perpendicular. So the model is dynamic in that if I move the sphere up and down inside the right cone, my parabola changes. That's because each time a new cutting plane is developed. So as we move the cone further up and down, a new plane is produced. This is done by always maintaining the relationship of the focal sphere being perpendicular to the cutting plane and the sphere being tangential also to the 2 extreme generators. So this results in a new directrix, a new focal point, and alternatively a new shape of our parabola. So the parabola narrows in and widens out, but it will always remain a parabola once this relationship exists for infinity, as you can see here by the dynamic model moving up and down inside the right cone. So the basic principles are, once again, the focal sphere is always tangential to the cutting plane to give us the focus point, or the focus or focal point. The directrix DD is obtained where an additional cutting plane is introduced to the right cone where the focal sphere meets the extreme generators of the right cone at a tangent. And the vertex then is obtained halfway between the focal point and the directrix, as this is a parabola. So once again, we can see everything remains the same. Our shape will always be a parabola. So thanks for watching, and I hope it was informative.